Okay, 8.4 binomial theorem. This is the last video of first semester, except for all the optional review videos. So for binomial theorem, we're going to review Pascal's triangle. So Pascal's triangle is written there for you. Pascal's triangle always starts with 1 at the top peak, and then the next line starts with 1, 1. And then you'll notice it always starts and ends. Each row starts and ends with the 1. But then can you look at it and figure out where the next number comes from? So for example, where does this 2 come from? Or in the next row, where does this 10 come from? I didn't go to the next row, sorry, I'm just jumping all over the place. But can you look at the triangle and figure out where these are coming from? So for the 2, since we're not in class and I can't wait for you to reply, 1 plus 1 equals 2. For the 10, 6 plus 4 equals 10. So why don't you fill out the next row? You know it starts with a 1. Look at the row above it. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And it always ends with a 1. There's all sorts of other patterns in Pascal's triangle, but that is how you build it. So if by chance you didn't have a calculator, which for what I'm about to show you, you could always build Pascal's triangle. It doesn't take a lot of time or space. Just start with those 3 ones at the top and then add for the gap below. What people have come to find out is that when you do combinations, if you do 0, C0, so if I have no items, how many ways can I organize, or how many ways can I grab those no items? Well, there's only one way to not grab any items. So 0, C0 can give you that 1 at the top. Same idea, if I have 4 items, how many ways can I choose none of them? There's only one way to choose none items out of any n items. Same thing at the far end of the triangle. If I have 3 items, how many ways can I choose all 3 items? Well, there's only one way to choose all 3 items. So that'll give you the 1s. And then it just so happens that if you continue with your combinations, so 1C0, and then just keep adding to it, 1C1, and then you're done with that row. But 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3. The combinations will give you Pascal's triangle. Then it just so happens that if you do expanding binomials, so we know x plus y to the 0. Anything to the 0 is 1. And that happens to match, what color do I want to use here? 1 happens to match the top of the triangle. Then if you just have x plus y to the first power, you just get x plus y. So you get 1x plus 1y, which happens to match the second row of the triangle. If you do x plus y squared, remember that's an area diagram. That's x plus y times x plus y, which is x squared, xy, y squared, which is 1x squared plus 2xy plus 1. That happens to be, the coefficients happen to be the next row of Pascal's triangle. If you wanted to do x plus y cubed, you'd have to get the answer to x plus y squared and then do another box, right? Because now we have x squared plus 2xy plus y squared, and I want to multiply it by xy again, and you'd have to fill out that whole box. But based on the pattern we figured out, Pascal's triangle will tell you what those coefficients are. 1, 3, 3, 1, 1x cubed, 3x squared y, 3xy squared, 1y cubed. So Pascal's triangle, or combinations, binomial theorem, help you expand these binomials much quicker. Because if I was doing x plus y to the 5th power, I'd have to finish this to get the answer to the 3rd power. Then I'd have to do this answer in another box with x plus y to get the next answer. Then I'd have to do that answer with another box of x plus y to get the final answer. And binomial theorem is just a much quicker way to get there. So if you like to see it in a nice, cozy little formula, we have, let's add to this, x plus y, not r. This is not supposed to be an r right here. That's supposed to be a y. Please fix that on your notes. So x plus y to the r power, the nth power, will be, you'll always do NCR first to get the coefficient, but then you have to do whatever's right here to the n minus r power, and then whatever's right here to the r power. And I'm going to show you, obviously, in a bunch of examples in a second. So, we want to expand x plus 3 to the 5th. Notice it's not always just x plus y, right? We're going to have numbers, we're going to have coefficients, we're going to have negative signs that we have to keep an eye out for. So different teachers teach this different ways. So this is how I like to organize mine for speed, honestly, because when you write things, it just works nicely to go vertically. So first, n equals 5. The exponent is n equals 5. So we're going to start with 5c0. Then my first term, keep it in order, is x. That gets all the exponents on it to the 5th, right? Because n is 5. And then my second term in my binomial is a 3. That starts with no exponents on it, 0. So if you look back here, notice, let's look at to the 5th power. It was x plus y. You start with x having all the exponents and y not having any of them. And then x counts down every time, while y is counting up every time. You start with 0 y's, and you have y to the 1st, y squared, y cubed, y to the 4th, until you have all y's and no x's. So that's how we set it up. Okay, here's what I do, though. I like to do all of them vertically. So next we're going to do 5c1, then 5c2, then 5c3, then 5c4, until we get to 5c5. You can't have more than n things. The x's are going to count down, like I just pointed out. So now it's going to be x to the 4th, x to the 3rd. The parentheses are important in the future, so practice it with the parentheses. X to the 0. The second term, which is a 3 in this example, counts up. It was 3 to the 0. Now it's 3 to the 1st, 3 squared, 3 cubed, 3 to the 4th, 3 to the 5th. So you can use your calculator. Well, first of all, anything C0 is always 1. Anything C itself is always 1 as well. Or you can go look at the 5th row of Pascal's triangle. So for Pascal's triangle, I forgot to mention, this is row 0, n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. There's our 5th row. So it's going to go 1, 5, 10, 10, 5, 1. But you can use your calculator for now. But I just said it's going to go 1, 5, what did I say? 10, 10, 10, 5. Check it out in your calculator to be sure. So now we're doing each little parenthesis. So I did the 5 C's. Now I'm going to move my 5th power to the inside, which I know it doesn't make a difference on this one, but it will make a difference on future ones. Bring your exponent onto the x. Anything to the 0 is 1. Now do the exponent on the 3. Anything to the 0 is 1. 3, 9, 81. I don't know these. The way I do this also makes it easier for you to type into your calculator. So I was at 3 cubed. Whoa, what happened? 3 cubed is 27. 3 to the 4th is 81. And then 3 to the 5th is 243. So you can just type those all in at once. It just makes it quicker, in my opinion, to do it this way. Then we multiply them together. These are all being multiplied. Parentheses next to each other means multiply. So that means my first term is going to be x to the 5th. My next term is going to be 15x to the 4th. 90x cubed. 270x squared. 81 times 5. 405 x, and then just 243. Do not leave it like this. I think this is a quicker method to do it, but if you just stop here, it's wrong. A binomial expression would be x to the 5th plus 15x to the 4th plus 90x cubed plus 270x squared plus 405 x plus 243. You need to give me the expanded binomial, not just a bunch of numbers in a row. Also, notice you don't see the triangle in your answer. The triangle showed up here, but because of the 3 in my problem, you don't actually see Pascal's triangle in the final answer. Okay, let's look at the next one. Okay, this one has a coefficient on the x and a negative sign, so we're going to be extra careful. N is 4. Your exponent is always n. So let's get started. 4c0. All the way up until I get to 4c4. The 2 to the x, the first term starts with all of your exponents and counts down. Your second term with the negative right there, this is where the negative comes into play. It needs to be there every time. The second term starts with none of your exponents and counts up. Make sure you included that negative in every single one of those. Okay, calculator or Pascal's triangle if you'd like. So on this one, you're doing 2 to the 4th and x to the 4th. So 2 to the 4th is 16 x to the 4th. So that's why the parentheses matter. 2 cubed x cubed. 2 squared x squared. 2x. Anything to the first power is 1. Include your negative. Anything to the 0 power is 1. Negative 1 to the first is negative 1. Negative 1 squared is positive 1. Negative 1 cubed is negative 1. It's going to alternate. Negative 1 to the 4th is 4. These are all multiplied together. This does not say 32x cubed minus 1. That is not what this says. This says 32 times negative 1. So let's multiply these all together. 16x to the 4th, negative 32x cubed, positive, right, because there's no negative sign, 24x squared, negative 8x, positive 1. So our answer is 16x to the 4th minus 32x cubed plus, since there's no negative sign, 24x squared minus 8x plus 1. Expanded form, this is our binomial expanded, and we didn't have to do any area diagrams. So biggest mistake is what I said right here. Students write this with an extra minus sign. There's no plus or minus signs until you get to the very end. And if there's no symbol at all, it's plus. And you write your answer down here. You try this one. Pause the video and try this one. I'm going to set it up. When you unpause it, my setup is going to be done. Pause your video. Okay, check your setup with mine. Then I'm going to go ahead and finish my rows. I'm going to do all the math. Pause your video. Basically, finish this problem. Pause your video and see if you can finish this problem. Okay, there's my work and my answer. Check yours with mine. Hopefully it matches. Okay, now I want you to look at something. If I wanted, let's go back to this problem, just because there's one more. If I wanted the third term, right? If I didn't want the whole binomial, I just wanted the third term. Clearly this is the first term, the second term, the third term. The third term would be 24x squared. What's something you notice about the third term? So the first thing I notice about the third term is that the exponent is 2. I was trying to find the third term, but my exponent ended up being 2. Also, if you look at where my work is for the third term, it was 4c2. Let's write this out. This was 4c2 times 2x squared times negative 1 squared. It's a coincidence that they're both squared this time. But my r is 1 less than the term number I'm looking for, right? I was looking for the third term, and my r was 2 in this problem. So let's look at the ones we're supposed to do. That's why they call it the r plus 1 term, because it's the number in the exponent is 1 less, r is 1 less than the actual term number you're looking for, or the question is asking for 1 more. So let's just jump right in. There's a little formula there if you love formulas. if I'm looking for the fifth term, I just figured out for myself that r is going to be 4, right? I just showed you on the other page, it's going to be 1 less. So this exponent is 9. Pay attention to the problem. So it's going to be 9c4. I know my parentheses are set up like this. Let's go back and look again. On all of our parentheses, this number, let's just go with 2, matched the second term. And then the other number has to equal r when you're done. So my 4 goes here. These two match. Whatever you put for r here is r here. And then math gives me the other number. This was a 9th power problem. So in order for my exponents to add to be 9, this must be a 5. So these add to be the original exponent. So instead of doing the whole row, or the whole column, I guess I should say, we just look at one row. So then you do 9c4 in a calculator. That's 126. X to the 5th is just x to the 5th. 2y to the 4th is 16y to the 4th. I multiply those together and I get 2016 x to the 5th y to the 4th. If I did the whole thing, that would be the 5th term. See if you can do number 2. 7th term. First of all, starts with 11. N is 11. 11c. 3x goes in the first parentheses. -1 goes in the next. Can you fill in all the stuff that's missing? So 7th term, because I'm starting at 0, that's why, right? We all understand that if you go 0, 1, 2, 3, 4, 5, 6, 7, you'd actually end up in a different spot. So 0 to 7, if I want 7 terms, is going to be 0 to 6, right? That gives me 7 terms, so that's 6. This one over here is also 6. And then together they have to make n, so this one must be 5. Do the math, use calculator. 11c6 is 462. 3x to the 5th is 243x to the 5th. And a negative to an even power is a positive. Multiply those together and you get 112,266 x to the 5th. That would be the 7th term. Okay, we will practice this some more in class as well, and I hope you guys are doing well.